Hello everyone, welcome back to my channel. As we turn our attention toward our next video, we want to focus our attention more on data analysis or dataset analysis than we have in probably the past. We want to look at some descriptive statistics of important variables, and we also want to begin to do some plotting. So in the next several videos, I'm going to be sharing with you how to do strip charting, how to do histograms, how to do some basic two variable scatter plots, etc. So notice that I've already called in the data set, but doesn't have 725 records. They have 745 because the medical director has revealed to me, oh, which of the patients are new and that have been treated upon their arrival in the hospital. So again, let's just confirm that we do have 745, and we can confirm that down here. You can see appended to the data set that had 725 that we added about 20 records, and where we identified those new records as being patients who had the treatment that we're concerned about. And so without further ado, let's take a look first of all at the mean, variance, and standard deviation of all of the records. And we see that the total 745 have a mean of about 12 days. That's not too different than it would have been if we just looked at the mean of 725 days, because 20 isn't going to have a tremendous amount of influence regardless of what the days may be. And we see that the variance and standard deviation are fairly large. So we have to get a very wide range, if you will, away from the mean in order to capture about 95% of the records. But first thing I want to do is I want to create a data frame that just extracts the records of the new patients. So I want to extract just 20 records from the data set because that's what I want to plot today and tomorrow and the next day. So the first thing we want to do is, how do I extract observations? And so if I want to extract just these first three observations, this is how I do it. I do a data frame and a bracket, and then I do 1:3, which means those are the rows that I want to extract. And then I have my famous comma and a blank there in order to tell the record that I want to look at all of the columns. So let's go ahead and take a look at that little mini data frame, and it has 3 records and it has all of the variables. And so now therefore with that understanding, I want to create a data frame called df treated, which will go and pick all of the values from 726 to 745, comma bracket. And that should get us the last 20 records in the data frame that I imported. And so let's just take a quick look at that. And while I'm doing it, I'm shortening the name just to reduce the typing involved. So I'm going to be taking a look at DF, capital T, standing for trade, treated. And so there is my records, my observations of the new records that were added to the original data frame. And so now we can begin to do some plotting, if you will, on either all of the records, or I can do some plotting on just a partial records. So why don't we go ahead and take a look at a strip chart of all of the 700 plus records and see what we're going to discover. And then I'll talk you through all of the parameters. So let me zoom that for us. So there are all of the 746 surgical records. This represents the mean. And you can see that it's not very normal looking. In fact, we call this a skewed left data distribution, and it has certain characteristics. If we were to look at the probability distribution of something skewed like this, we would end up calling it a gamma distribution. So, but that's not our real goal right now, is we just want to examine the data. We don't want to draw a lot of conclusions about the data, but we can say, well, it is skewed to the left. We now discover the mean of 170 for 6 of the surgeries. So let's go see what the strip chart does first. The strip chart is a function, so I have my brackets at the beginning and the end, and then I identify parameters. The first parameter is that I have to identify the days as being the variable that I want. And the reason that I didn't have to put in $days is because when I attached it up here, I attached the entire data set. If I just wanted to do days for my treated subset, I would either have to attach this DFT or else I would have to put that in front of my days variable. And the method is really saying, look, I want to stack each of the observations. You can see the little dots here, of course, which we showed when we were looking at the zoom plot. But I want to plot each observation in a stack, is really what it's saying. We're not measuring, I don't care what the frequency is at this particular point. I don't need to count on this like I will on a histogram. I just want to stack the observations. And so you can see that at about 4, I have the smallest number of observations, and I might even have one way down here at 1. And the at parameter is actually telling me where I want to start the bottom of the plot. It's not very attractive kind of plotting, but in an event that PCH and 20 is telling me that I want a little filled in circles. The CEX equals the 0.5 is telling me the kind of size, font size that I'm going to be using up here in my title. Last is orienting my numbers in a way that I can read them like a normal human would, etc. And X limit is setting limits on the X axis. And then of course, main is printing a title. And the AB line is a function. This is a function that's going to plot a line. It's going to plot a vertical line. It's going to plot at the day's mean for the DF data set. It's going to be red. And then we identify the type of line, which in this case was a dashed line. And this identifies LWD, how wide I want the line. So in the interest of time, I'm going to stop with the strip chart and we'll continue with other strip charts and histograms in my next videos. Thank you for joining me.